All right, guys. Lesson 3, stem and leaf plots and how we use them in conjunction to analyze data sets. So if you're just looking to talk about data sets, we generally tend to organize them in a stem and leaf plot because they let us make some meaningful inferences um, and use our 4 measures of central tendency to analyze the data. Now, measures of central tendency is the fancy name we give for mean, median, mode, and range. All right, so some of you are able to do this on the diagnostic and some of you couldn't, which is okay. So we're going to go over it today in today's lesson as well. So we're going to go over stem and leaf plots and how to change data sets into them. Then we're going to take a look at how to calculate mean, median, and mode, and what we can do, or how we can analyze or use mean, median, mode to make inferences about the data, okay, or the data sets. So again, this stuff's only supposed to be used with Math Makes Sense, grade 7, the textbook. We're working on chapter 5-3. So yeah, so anyways, we're going to change these science scores into a stem and leaf plot. And here's how you go about doing it. There's a bunch of ways, and I'm going to show you one. You can choose to use it or you can choose to ignore it. Here's what I would do. First off, I would take a look at this data set here and I would organize it from the least value to the greatest value. Makes it a little easier to do that when it comes to generating a stem and leaf plot. It's that, or you can go ahead and just start generating the stem and leaf plot right away. But I'm going to organize them least to greatest because that's what I like to do to organize it into a stem and leaf plot. All right, I'm going to pause the video. So I've started doing it here. 52, I would go ahead, I'd cross out 52. I've used it, write 52 here. The next value, oh, looks like 53. I'd cross it out. I'd write 53 here, comma. It looks like the next value is going to be 50. 57. So there's a 57 here, and then there's a 58. I just saw the 58 back up here. So 57 comes next, and then it would be 58. All right, I'm going to pause the video and finish this off. You guys go ahead, do the same thing, and then hit play, and you can double check against mine. Those of you that just outright copy aren't going to get as much out of this video. All right, so I've gone ahead and I've gone from least to greatest and gone through all of them, just organizing it. I had it listed off on the side, which is why I don't have all this crossed out. You guys can have it crossed out. Now, you can actually just use this data set here to generate a stem and leaf plot, but if you make mistakes, you got to start crossing stuff out and reorganizing stuff. Generally, it's easier to do if you make one giant long list, all right? So we're going to organize it into a stem and leaf plot. Now, stem and leaf plots kind of look like our tally or frequency tables. It's just there are only 2 of them. This side here is commonly referred to as the stem side, and this side here is referred to, stem side. And this side over here is commonly referred to as like the leaf side, okay? Essentially what we do is we take, like, say 52 and we cut it up and we put the tens column here. All right, so we're gonna, for this stem and leaf plot, this side here is gonna represent the tens of the science score, and this side here is gonna represent like the ones, right? Because that's what these are. They're science test scores in a class. All right, so take a look. It starts in the 50s here and it ends up in the 90s. So going down, I'm gonna have, like 5. Numbers that start with 6, numbers that start with 7, numbers that start with 8, numbers that start with 9. No one got 100. All right, so these are what we call my leaves, or sorry, my stems. All right, they're here. They started. Now, instead of writing things out in a giant list like this, what we can do is we can organize it into the numbers cut kind of in half is about the easiest way to say it. All right, so the stem and leaf. So the stem for 50 is 5, and then the leaves would be the 2, the 3, the 7, and the 8. I'm just going to organize this for a sec. You guys have the ability to go right across. I'm trying to, limit the amount of cheesy handwriting I have to do. All right, so there, that kind of lines up. And then we move on. So then you organize your 6s, and it goes 61, comma 64, comma 65, 66, 67, and then 69. I'm going to pause the video and finish this off. You guys finish off the stem and leaf plot as well to the best. Oh, I messed up. This should just be a 1. Sorry about that. 1, 4. Even I make mistakes at my age. 5, 6, 7, 9. After doing this for so long. So this is not supposed to be the 60s, but these combined are supposed to represent 61, 64, 65, that sort of thing. Pause the video and finish off. So if you went through and finished off organizing all of these, your stem and leaf plot should look like this, okay? And it allows us to make inferences about the data itself. We're able to quickly spot, and even though we're doing this list, we could quickly spot what the low value and the high value is. You're able to actually start making meaningful inferences about where the middle of the data is. It looks like the middle of the data is in the 70s, probably somewhere around 75 to 77. I know that the majority of the class seems to get their scores in the 70s and 80s because these are the two longest column sets. I know that the lowest score is 52, the highest score 99. That would be the range. The most popular seems to be a tie in between the people that had 81 and the people that had 75. There's three of them that had each of them. And you can start seeing things a little easier with the stem and leaf plot. It's not quite as easy to spot in the list, although you could probably pick out the mode. It would probably help you figure out where the middle is. Doing the average, you can't really spot by eye. So when you're doing stem and leaf plots, you could order them this way, or you could just start making it this way. But if you miss one, you're going to have to erase it. Like if you put the 66 down before you realize the 65's there, it might be a little harder to organize. I don't know. It'll be up to you. You don't necessarily have to order them least to greatest at the start, but it might make it easier to make the stem and leaf plot. All right. Turn the page over. I'm going to give you quick definitions on mean, median, and mode, and then I'll probably end this video and then finish off the rest of this question. Okay. Flip over to page 2. So down here, the mean, we're going to go through mean, median, and modes. It's how we, and range, it's how we analyze data sets. All right, now I'm going to kind of jump around. I'm not necessarily going to start with the first one. The mode, verbal definition of it, if you've forgotten, the mode is the most common number, is the most common number or pair of numbers. All right, so if there's two numbers that are most common, go ahead, say like, if there were two sixes, say in this data set up here, 3, 5, 6, 9, 9, 10, you could say it was 6 and 9, or you could say neither, because, there's a bunch of them. For the most part, if there's a pair of numbers, go with both of them. If there's like there's 3 or 4 numbers that all have the same number, say there's no mode. All right, so it's up to you to interpret. In this case, it's the most common number. 9 would be the mode for this data set. All right. So these are kind of like your definitions. The most common number or pair of numbers. Range is the lowest to the highest number. It's nice, it's easy. We have another definition for range. So the first one is simply the lowest to the highest number. So 3 to 10 in this case. Okay. Or it's the difference between the lowest and highest number. So 10 minus 3 equals 7. So it has a range from 3 to 10 with a difference of 7, right? So there's 7 values in the distance. Now median, in order to do the median is when you line things up from the least value, line up the values from least to greatest. It's the absolute middle value, all right? Now, if you have an odd number of data sets, it's just like, say, if we had 5 values, if we didn't have this 10 picking around here, we only had 3, 5, 6, 9, and 9, the middle value would be 6. We have an even number of values. So you need to find the two middle ones. We have 1, 2, 3 on this side, and then 1, 2, 3 on this side. We add these two numbers together and divide by 2, all right? So if it's an odd, and I know how this is going to sound, number of numbers, it's the middle value. Even, find the middle pair of values, add them up, divide by 2. In this case, it works out to be 6 plus 9, I know I did that backwards, equals 15. If we divide 15 by 2, we end up getting 7.5. So the median in this data set is 7.5. Now, even though 7.5 isn't an actual number in our data set, that's what the median is, 7.5, right? The value in between 6 and 9. The last one before I end this video, and we'll go back and finish the question off in the next, the mean. Another way of saying average. Add the numbers up and divide by the number of numbers. So in this case, we would add 3 plus, hello Watson, let's go. 3 plus 5 plus 6 plus 9 plus 9 plus 10. 10. Hello, 0. 10. And we'd have this all over. In my case, because I'm using a computer, it would look like this with brackets. So we need to follow BEDMAS and do that first. And then we divide by 6. So in this case, it's 3 plus 5 is 8, 8 plus 6 is 14, 14 plus 9 is 23, plus 9 is 32, plus 10 is equal to 42, and then 42 divided by 6 equals 7. 7 would be the mean or the average in this case. All right, I know this is kind of a longer video than I intended. We're going to flip back to the first page in a sec, and we'll finish off the question we were working on. This was to review what mean, median, and mode and range were. Okay, and we'll flip back now.